with regards to the COVID-19 pandemic,
Yes.
with regards to the vaccine, are you for or against it? I hear so many different views from people,
Mm,
whether they are going to take it or not. Could
mm.
you maybe give us some advice in that respect?
Sure. So maybe I will do so with my science hat on, if that's okay. So my background, I have a Bachelor of Science degree in cellular microbial biology, and I have a PhD candidacy in molecular virology. And I did my biochemistry during that time and then went into medicine. So I feel like I have the adequate kind of research science background to comment. So hopefully that qualifies my opinion. So my opinion is that firstly, we need to recognize that there is genuine vaccine hesitancy out there, that it is a scenario where people say, but what actually happens to my body? What potential harm can occur from me putting something in my body that normally wouldn't belong? And so we have to firstly acknowledge that vaccine hesitancy, but make sure that we tackle that vaccine hesitancy with facts, with science, with understanding. And so, vaccines, firstly, the fastest vaccine that was ever made in the past was the mumps vaccine. And it took 2 years. And it was considered a fantastic accomplishment. If you look at vaccine technology, if you look at HIV, we've been working on HIV for the last 20 years, and we still do not have a vaccine. So vaccine development is extraordinarily difficult. It requires the best innovations of science. What I love about our vaccines for COVID-19 is that we've used the latest, greatest science technology, and several groups that are very different in terms of where they're located and the science behind them have kind of come to the same vaccine technology together, whether it be Oxford, whether it be AstraZeneca, whether it be J&J, whether it be Pfizer, Moderna. So these vaccines have used a new technology where it's no longer the virus itself coming in to you. It's no longer a modified virus coming into you. It's no longer a virus that's been broken up and injected into you. The vaccine that we're talking about today is essentially a component of the virus genome. So that part of the genetic sequence that allows that virus to produce one of its proteins, that small segment of that viral genetic map is injected into us. Our cells take up that little segment of genome, and it goes through our cellular machinery to produce the one same protein that the virus produces, called a spike protein. It's that little spike that sticks out of the globe, and when you see that spike, that's the spike protein. So what happens is our body says, oh, this is a new protein. I've never seen this before. The immune system then reacts to that protein that says, I'm going to treat this as a foreign protein and get rid of it. So we kick in two parts of our immune system, the one that produces antibodies and the one that fights viruses, one called the B cell system, the other the T cell system, and both are kicked in to fight that one protein. So our system then, upon seeing, after 4 to 6 weeks of seeing that initial protein injected into our arm, now says, if it shows up again, I will get rid of it. So today's technology is ultra fantastic, where we use our own cell machinery to induce an immune response that now is going to attack the presence of that protein. So now if we get exposed to the virus, the COVID-19 comes our way, and we have those antibodies and the viral immune system to knock out that spike protein, we do not get infected. We have a 95% vaccine rate, which means those that get the vaccine are going to become immune after the second dose. It's about 75% after a single dose. So to improve that, that's why we have that second dose. And that window of the second dose can be extended by the look of the newer studies that are coming out. So am I excited about it? Absolutely. As a past scientist or scientist that likes to follow that world, this is the latest, greatest technology. It's the safest vaccine probably we've ever seen. There is always going to be vaccine hesitancy because people would rather not have to take it. But on the other hand, wow, look at our world without it. It is truly turned upside down. And no matter what corner of the world you're in, it is devastating when you lose a loved one or you watch someone suffer or they end up with a chronic illness because of this virus. To me, I would say most healthcare workers that have paid attention will be the first in line. And the long-term care facilities should be the second, and those vulnerable should be the third, and those in the front lines, whether you're cleaning the rooms or cleaning the beds or taking care of people in the ICU as a doctor or a nurse, those front care workers need to be first. And workers, I'm including the support staff. So yeah, we all have to wait. I'm not till phase 3 because I'm not in the hospitals. I'm not seeing the critically ill patients. Yes, I'm seeing them in my clinic, but not sick patients. So we have to take our turn. I think it is fabulous technology. The governments are behind us making sure that you don't pay for it, that you get it no matter if you have $1 in your pocket or many dollars in your pocket. So I think the approach is right. Everybody wants it faster than we can get it because it's a manufacturing issue and a distribution issue. But I think by the end of this year, if you probably want it, you can get it. And that's pretty darn good. So that's a lot of words to say yes. When it's my turn, I'll be in line. And would I hesitate? No. And if you are sick with a chronic illness, if you're immune compromised, the more recent data says it's safe. If you're pregnant, it says it's safe. If you are breastfeeding, it says it's safe. So even our preliminary data in those individuals with their own special needs at the moment, the data certainly is there to say so far so good.